Your agent searched the web. It ran a command. It queried your database. Except it did none of those things. Not once, not ever. There is no such thing as calling a tool. Once you see what is actually happening, 4 different bugs you have been fighting stop being mysterious. Let's open it up. Here's what you see in the interface. You ask what's in a config file. The agent calls read_file, the tool comes back, and it tells you the answer. Every agent product renders some version of this. A little tool badge, a spinner, a check mark. It reads like the model reached out into your machine and did something. That rendering is a fiction, and it's a useful one right up until you have to debug it. So here is the whole truth, and it is almost disappointingly small. The model produces text. That is the complete list of things a language model can do. It has no network access, it has no file system, it cannot execute anything, and it cannot wait for anything. It receives a block of tokens, it emits some tokens, and then it stops existing until you call it again. Everything that looks like action is something else in the system doing the acting. Step 1. Before the model sees your question, you put the tools into the context as text. A tool definition is not a connection, not a handle, not a capability. It is a paragraph in the prompt that says, here is a thing called read_file, here is what it does, here are the parameters it takes. Name, description, parameters. And as we established in Lesson 1, that block is resent on every single call, used or not. All you have done is tell the model what shape of output would be meaningful. Here it is literally, a JSON blob with a name, a description, and a parameter schema. You write this thinking of it as configuration, a wiring declaration, like registering a route. The model does not experience it as configuration. It flows into the same token stream as everything else, and it gets read the same way your question does, as prose, with all the ambiguity prose has. Hold on to that, because it is why the description field does far more work than the function name, and we'll come back to it. Step 2. The model reads all that and produces its output, which is, as always, text. But this time, the text is shaped like a call, the name of a tool, and some arguments. And I want to be blunt about its status. That output is not an action. It is not a request that leaves the model. It is a string with exactly the same standing as a sentence about the weather. It just happens to match a shape that you agreed in advance to go looking for. Step 3, and this is where the illusion actually lives. Your loop, your code, the framework, the agent harness, takes that output, parses it, sees it matches a tool you registered, and calls the real function. The one that actually touches the disk. And notice what the model is doing during all of this. Nothing. It finished. It is not waiting for the result, because there is nothing there to wait. Between the call that produced that output and the next one, the model does not exist, which means every tool result has to be delivered the only way anything gets delivered. Step 4. Your code has the file contents. Now it has to get them to the model. It appends them to the transcript as text and calls the model again with the whole thing. There is no return value. There is no callback, no channel, no resumed execution. The result of your tool is a new paragraph in a document, and that document gets sent from the top. The model reads it fresh as if seeing it for the first time, because it is. So here is the whole thing on one line. Model writes text shaped like a call. Your code parses it and runs the real function. The result gets appended to the context as text. The model is called again and reads it fresh. Round and round, until it produces text that isn't shaped like a call, and your loop stops. That is the entire mechanism. Every framework you've used, every protocol, every agent product, all of it is ergonomics on top of this loop, which means the 4 things that go wrong are not mysterious. They fall straight out of the shape of it. Consequence 1. The model chooses a tool by reading its description in prose alongside everything else. So the description is not documentation about the interface. It is the interface. And most tool definitions are written like a code comment, for a colleague who already knows the system. Search searches for things. The model has no idea what that means, when to use it, or what it competes with. Write it for a competent new hire on their first day. What it's for, when to use it, when to use something else instead, and what comes back. That paragraph will outperform any amount of clever prompting around it. Consequence 2, and this one stops being surprising the moment you see the mechanism. The model can produce a call to a tool that does not exist. It can invent a parameter, or use one you deleted last week, or reach for a plausible-sounding neighbor of the real name. Nothing prevents this, because there is nothing in between. There is no compiler sitting between the model and your loop. It writes text, and text is allowed to say anything, which means validating the call and returning a useful error is your job, and it's not optional. Consequence 3. The model has no view into your system. It did not watch the function run. It knows exactly one thing about what happened, the text you appended. So if your error says operation failed, the model has nothing to work with, and it will do the only reasonable thing. Try the identical call again. That's your infinite loop, and it isn't stubbornness, it's starvation. Say what went wrong and what will work instead, and it will use that. Your error messages are prompts. They're read by the thing deciding what to do next, so write them for that reader. Consequence 4. In Lesson 1, I said that adding tools makes agents worse, and promised the reason would land here. 40 tools are not a menu that gets scanned. There are 40 paragraphs of prose sitting in the window at once, each one arguing for its own relevance. And the real problem isn't the count, it's the overlap. 2 tools that could both plausibly apply is a much harder problem than 20 that obviously can't. So when you trim, don't just cut the least used. Cut the ones whose descriptions blur into each other and make the survivors say explicitly what they are not for. So here's the thing to keep. Tool calling is a formatting convention, not a capability. Models were trained to reliably produce a particular shape when a description suggests it, and everything else in the chain is your code honoring that shape. And that's genuinely good news, because it means the parts that decide whether your agent works, the descriptions, the validation, the error text, which tools are even visible, are all parts you own. None of it requires a better model. Concretely, in order of payoff. 1. Rewrite your tool descriptions for a new hire. What it's for, when not to use it, what comes back. This is usually the single highest return change in an agent codebase, and it takes an afternoon. 2. Make every error message say what would have worked instead of what failed. 3. Cut tools whose descriptions overlap with each other. And 4. Validate arguments before you run anything, because nothing upstream did. One thing worth heading off, because it's the obvious question. Does a protocol like MCP change any of this? No. What those standardize is how tools get discovered, described, and transported between systems, which are real problems and worth solving. But underneath, at the point where the model is involved, it is still a description in the prompt and a shape in the output. Nothing about the mechanism moved, which is worth remembering when a server offers you 50 tools in one click. That has handed you a context problem, not solved one. 2 places where I simplified. First, providers do constrain the output. Structured decoding and grammars make a malformed tool call much rarer than I implied, and that's a real improvement. But look closely at what it constrains. The shape of the output, never whether the tool was the right one or whether the argument makes any sense. Second, parallel tool calls and streaming exist, so several tools can run at once and results can arrive in pieces. Genuinely convenient. And underneath, the loop is exactly the one we just drew. Text out, your code acts, text back in. In one breath, then. Tools are described in the prompt as prose. The model writes a shape. Your code parses it and does the actual work. The result comes back as text, and the whole context is sent again. Every failure you have with tools lives in one of those 4 steps, and 3 of the 4 are yours. The model's part is the one part that already works. So that's the mechanism, and it's smaller than the vocabulary around it suggests. The model never called anything. It wrote a shape, and your code honored it. Next time we take the failures, we keep brushing past the loops, the context rot, the invented tools, and work out which are the model's fault and which are ours.